Right, so here are a few ratio problems regarding centripetal force to help you out. It says here the centripetal force FFC of an object can be calculated using this particular function, mv squared over r, where m is the mass or the object's mass, v is the object's velocity, and r is the radius of the circle. It says here if the radius of the circle is reduced to r over 4, so 1/4 of it, the forces changes by a factor of. And here are your choices. So let's crack it up. I think to do these types of problems super quick, set up a little t-chart before and after. Here, you're given the function f of c is equal to mv squared over r, so all you have to do is really apply it. The question is asking to compare forces, yeah, because here it says the forces changes by a factor of. So I don't really have to do any manipulation here. Right away, I'm just going to use f of c is equal to mv squared over r, and then on the right side, I have f of c new, which is equal to mv squared over r new. Okay. Now, the v stays the same because it didn't say anything about v changing. It says if the radius of the circle is reduced to r over 4, right? So here in the numerator, well, the mass hasn't changed. The speed hasn't changed. The only thing that did change, according to the statement, is this radius on the bottom. Hence, I just call this r new. Well, I'm just going to listen to the statement and replace it what it needs to be. mv squared stays the same in the numerator, but r new is now r over 4. Why? Because it said so. It says the radius is reduced to r over 4. So my new r is r over 4. So as you can see here, you have mv squared divided by a fraction. This is r over 4, which is a fraction. So you need to keep in mind to do your algebra correctly. So because you're dividing by a fraction, I made a statement here for you, multiplied by the reciprocal. Okay, so it's important that you do your algebra correctly. And if you do that, flip the 4 top, the r stays in the denominator. So therefore, we have mv squared times 4 divided by r squared. So here, I'm just going to pull the 4 out because it's mv squared times 4. So you can put the 4 out. When you multiply, it doesn't really matter whether the coefficient, whether it's at the end or in the front. I like it in the front because, excuse me, that allows me to factor out things and then just recognize the substitute. So here on the left side, our original statement is f of c equal mv squared over r. Here, I know mv squared over r is f of c, so therefore I can recognize that I have mv squared over r on the right side as well. So therefore I can just substitute quickly, and that is 4. Okay, so fc new is 4 times f of c, because all this stuff here, mv squared over r, can be replaced with just the original f of c. So the answer here is 4, which is f. All right, let's do the next one. The next one's same type of scenario, except here it says if the velocity changes by a factor of 3, right? The previous problem, the radius changed. In this particular problem, the velocity changed. And it says what the forces changed by a y factor. So we're still looking at forces. So I'm just going to do a before and after again. I want to start with my parent function, I call it. F of c is equal to mv squared over r. Here on the right side, I'm going to have f of c new, because once again, you're comparing the new force. M stays the same. R in this problem stays the same now, you see, because it only says the velocity is changing. So here I have v new squared, but v new is changes by a factor of 3. Also, I'm just going to multiply by 3. But it's important that you substitute v new for 3v, but in parentheses, okay? Because the whole quantity is being squared. All right, so here I have m. Well, I need to distribute this exponent to the 3, which is 9. And then v is going to be square as well. So if you do that correctly, 3 squared is 9. I like to pull the 9 out in the front. And you have mv squared over r. And hopefully if you understood the previous example, I like to pull out the 9 in the front here. You can keep it in the numerator if you want. So it's up to you how good your algebra is. Here you have mv squared over r. But once again, I'm going to highlight mv squared over r on the left side, which is the original f of c. I'm going to substitute it out over here. So mv squared over r can be replaced with f of c because it is, and then therefore the answer is just 9. Why? Because the coefficient here is a factor of 9. So the answer is A. All right, so here, this one's a little wordier. It says a car goes around a curve of radius 1 at a speed v1. It says a little down the road, the same car goes around a second curve of radius r2. But r2 is half of r1, and then the speed for the second curve is half of the speed of the first scenario, okay? So it says, what is the centripetal force on the car as it navigates the second curve compared to when it navigates the first? So what is the ratio of FC2 over FC1? Well, here are your choices, so let's crack this out. Here, there are a couple of things changing. R is changing, V is changing. So I want to start with my fundamental function again. Here, I have two scenarios though, f of c1. I'll just use subscript 1 because in the statement it says R1 and V1, R2 and V2, so I'll just use the same subscript. Here, before is scenario 1. The mass doesn't have a subscript because it's the same car. V1 square over R1. I don't know what that is. It doesn't really matter here because you're just doing a ratio problem. Here, f of c2, which is equal to mv2 square over R2. So I'm just going to swap out what needs to get swapped out, okay? It says here the speed is now half because 1/2 of V1, which is the same thing as saying V1 divided by 2. Likewise, R2 is now R1 divided by 2. Multiplying by 1/2 is the same thing as dividing by 2. So I'm just going to swap out these statements. M, I carry it down, that stays the same. But instead of V2, I want to write V2 as V1 divided by 2. And I'm going to close parentheses and want to square that. And once again, R2 in the statement here, it says R2 is 1/2 of R1, and 1/2 of R1 can be rewritten as R1 divided by 2. So here I'm just going to go ahead and distribute. V1 gets the square, the 2 on the bottom also gets the square, so make sure you distribute properly. Therefore, I have mv1 square divided by 4. The denominator stays the same because it's just R1 over 2. But then I'm just going to clean this up a little bit, okay? I made a reminder for you just like the last one because you're dividing by a fraction. Make sure you multiply by the reciprocal. So if you do that correctly, here in the numerator you have m times v1 squared divided by 4, which is mv1 squared divided by 4. And then you have to flip the denominator fraction upside down. So therefore the 2 goes in the numerator now and the r1 stays in the denominator. So as you can see, if I were to clean this up a little more, I can pull the 2 out front, I can pull the 4 out front. And then really, I just have mv1 squared divided by r1, which is right here. But keep in mind, 2 over 4 is the same as 1/2, okay? So I can clean this up a little bit. So I can say this new centripetal force around the second turn is 1/2 mv1 squared over r1. But then if you look on the left side, your reference point, your original location, turn 1, the centripetal force for the first scenario, first curve is mv1 squared over r1. And I can substitute that out. Okay, so learn to recognize what's the same, factor those things out, and just do a quick substitution. So therefore, the answer for this one is 1/2. Why? Because there's a coefficient of 1/2 in the front. So that answer is B for this one. And then last but not least for this video, it says here a car going around a curve with radius r at a speed v experiences a centripetal acceleration. So here it involves acceleration rather than force, AC. Is it what should the radius of the path leads to the same centripetal acceleration while it travels at a speed of 2v. Okay, so here are your choices. The only thing that is changing is our speed. So once again, I'm just gonna go ahead and write out my fundamental. I'm sorry for my dog barking. I think my mom just arrived, so she gets all excited. AC is v squared over r, and then here on the right side, I do want to point out that it says the same centripetal acceleration. So you notice here, for this particular problem, I did not write AC new because it wants us to keep the same centripetal acceleration. Okay, so the only thing that is changing is v squared. And then because v is changing, and if for AC to stay the same, r has to change to compensate for it. All right, so I'm just going to substitute out v new squared for 2v. Once again, I use parentheses because it says here it travels speed of 2v. So the new speed is now twice as fast. You distribute the exponent, as I've done in the other slides. Here, 2 squared is 4, okay? And then r new is just r new, but you notice here, I just replace AC with v squared over r because it is AC on the left side is v squared over r. So because it's the same, I can do that quick substitution here. And then here, you notice that v squared will cancel out because it appears on both sides. And here I'm trying to solve for r new, so I want to move r new to the top left numerator. I want to move this r to the top right numerator, so do a little crisscross action there. So therefore, we have r new, which is equal to 4r. So the answer for this one is going to be C, because that is 4r. All right, other than that, I hope that helps. Stay nerdy, don't be back.